Welcome to lecture 2 of statistical estimation. So let's start our lecture with the next part, which is estimating the differences between two means. So we discussed the confidence interval of a mean and confidence interval of a population proportion. So in this lecture we'll talk about the confidence intervals between the difference between two means. So you have again the same data, but you have two samples of n1 and n2, and you have two populations with mu1, mu2 and sigma 1 square and sigma 2 square. So this is the data that we generally need. So the estimator for mean is the estimator for standard deviation here is the variance, the sample variance. Sigma 2 square will become s2 square. So based on this data, we are trying to assume the inference for x1 bar minus x2 bar, and if the populations have the same difference, the two populations averages are the same, then mu1 minus mu2 is 0. But we are trying to estimate the difference between the two populations, mu1 minus mu2. So for this data here, the mean x1 bar minus x2 bar is the estimator for mu1 minus mu2, and the standard deviation for this is under root sigma 1 square by n1 plus sigma 2 square by n2. And both of these n1 and n2 should be greater than or equal to 30. So n1 should be greater than or equal to 30 and n2 should be greater than or equal to 30. Only then will this assumption work, unless it is mentioned that it is approximately normal. Now the standard error is basically replace sigma with s, that you get the sample standard deviation. From that you get the standard error. So in terms of the point estimate, it is x1 bar minus x2 bar. The margin of error is plus or minus z alpha by 2 into square root of s1 square by n1 plus s2 square by n2. So the confidence interval is x1 bar minus x2 bar plus or minus z alpha by 2 under root s1 square by n1 plus s2 square by n2. So this is the confidence interval. So again the same, if it is 95% confidence interval, then z alpha by 2 is 1.96. If it is 99% confidence interval, it is 2.575. If it is 90% confidence interval, the value is 1.645. So remember, the common values are still the same, so we are still going to use the same exact values. So let's use this data now. What is given here? So a research team is interested in the difference between serum uric acid levels in patients with and without Down syndrome. So with Down syndrome is one population, without Down syndrome is the second population. So in a large hospital, for the treatment of mentally retarded, a sample of 12 individuals with Down syndrome yielded a value of x bar of 44.5 milligrams per 100 ml. In a general hospital, the same 15 normal individuals of same age and sex were found to have x bar of 3.4. It is reasonable to assume that the two populations are normally distributed with the variance 1 and 1.5. Find the 95% confidence interval. So write down the data that we have here. x1 bar is 4.5 and x2 bar, I'm not going to write the units because you already see the units in the question. So the x2 bar is 3.4, n1 is 12, n2 is 15, sigma 1 square is 1, sigma 2 square is 1.5. So we have everything that we need. So we are trying to find the 95% confidence interval. So the formula is x1 bar minus x2 bar plus or minus z alpha by 2. So because it's 95%, we can directly write the value 1.96 into square root of s1 square. So remember that sigma 1 sigma 2 are the values for s1 and s2. So we can consider them as s1 and s2. So it becomes 1. So the formula is s1 square by n1 plus s2 square by n2. So substitute the values. You have 4.5 minus 3.4 plus or minus 1.96 into square root of s1 square plus s1 square by n1 becomes 1 by n1 is 12 plus 1.5 by n2 is 115. So use a calculator, pause the video right here and try to solve these values. So when you solve, you get 1.1 plus or minus 1.96 into 4.4282. So that will give you a values of 0.26 comma 1.94. So this is the value of 95% confidence interval of the difference between x1 bar and x2 bar. So pause the video right here, do the same exact problem here. Here they have given a sample standard deviation, so this is sigma 1 and sigma 2. This is x1, x2 bar and x1 bar. This is n1 and n2. So you have everything that you need. So pause the video right here. I'm sorry, this is s1 and s2. So pause the video right here and try to solve and try to find the 95% confidence interval. So use these problems for practice. So pause the video right here and try to solve these problems. Next, let's come to the next topic, is the difference between two proportions. So we have two populations with two different proportions. So you have sample size n1 with proportion p1 and sample size n2 with a proportion p2. So for this, we have n1 and n2 is the sample size. We have to find p1 cap and p2 cap, which is x1 by n1, and p2 cap is x2 by n2. Sample variance is p1 cap q1 cap by n and p2 cap q2 cap by n, and the standard deviation is the square root of the sample variance. So p1 cap minus p2 cap is the one that we estimate. We are trying to find p1 minus p2 is the population difference between the population proportion. P1 cap minus p2 cap is the difference between the sample proportions. So the standard error again is square root of the sum of the variances of individual values that we have. So again, the confidence interval is p1 cap minus p2 cap plus or minus z alpha by 2 into square root of p1 cap q1 cap by n1 plus p2 cap q2 cap by n2. So this is the formula for confidence interval. So the assumption here is that it should be large enough that you have n1 and n2 should be larger, as well as the difference between the values added with 2 times the standard error should be between -1 and 1. So only then we can understand, we can use this formula. So let's try this problem here. So what is given here? So the sample population 1, male is 80, female is 70. So n1 is 80, n2 is 70. P1 is, remember that they have given playing soccer, so we want to find the proportion of people who play soccer. So out of 80 male students, 65 of them play soccer, so it becomes 65 by 80. P2 becomes 39 by 70. So this is the data that we have. So write it down as a percentage. So we have 65 divided by 80 becomes 0.8125. So remember that this is P1 cap and P2 cap. So P2 cap here is 39 by 70. So that becomes 0.5571. So you have the values for P1 cap and P2 cap. And they have also given us N1 and N2. So we have to find Q1 and Q2 first. So Q1 cap and Q2 cap. So it is 1 minus P1. So 1 minus 0.8125 becomes 0.1875. Q2 cap is 1 minus P2 cap. So that becomes 1 minus 0.5571. That becomes, the value becomes 0.4429. So we have everything that we need from the data. So now let's try and solve the problem. They are asking us for a 99% confidence interval. So based on that data, we know the formula is P1 cap minus P2 cap plus or minus Z alpha by 2 into square root of P1 cap Q1 cap by N1 plus P2 cap Q2 cap by N2. So you have P1 cap minus P2 cap. The value for P1 cap is 0.8125 minus P2 cap is 0.5571 plus or minus Z alpha by 2 when the value is 99% is 2.575 into square root of 0.8125 times 0.1875 over N1, the value is 80 plus 0.5571 times 0.4429 divided by 70. So from the data that we have here, so the value becomes, so try to calculate 0.8125. minus 0.5571. So that value is 0.2554 plus or minus 2.575 times square root of. So first let's find the first value, which is 0.8125 times 0.1875 divided by 80. So that value is 0.0019 plus you have 0.5571 times 0.4429 divided by 70. So that becomes 0.0035. So add the two values and finally square root the two values. So you get 0.2554 plus or minus 2.575 times 0.0736. So we have to now multiply this value with 2.575. So you have 0.2554 plus or minus 0.1895. So when you want to write down, you get 2554 minus 0.1895 comma 0.2554 plus 0.1895. Now based on this data, you have 0.2554 minus 0.1895, that becomes 0.0659 comma 0.2554 plus 0.1895, that becomes 0.4449. So this is the 99% confidence interval for P1 minus P2. So these are the values for the 99% confidence interval between P1 and P1 minus P2. So hopefully you understood how to solve this problem. So use this principle here and try to solve these two problems. So pause the video right here and try to solve these problems. So next let's go to the last topic, which is small sample estimation. Small sample estimation involves where you have n1 is less than 30 or the distribution is not normally distributed. So what do we do then is we use a different distribution here. So small sample estimation involves when the sample size is small and the estimation procedures for large samples are generally not appropriate because the point estimators will remain the same but the central limit theorem will no longer work. So the point estimator will stay the same but the reliability coefficients are the ones that are mainly the problem. So what we do here, we get the reliability coefficients from a different distribution. We call it the student t distribution. So student t distribution was developed by W.S. Gossett. It's also called as the Gossett's t distribution, but the common name is student's t distribution. And it is the correct sampling distribution that we use for mean of the samples less than 30 and we call it the t distribution. So what are the properties of t distribution? It's similar to the standard normal distribution, but the difference here is that it is not one single curve, it's a combination of multiple curves. So it is symmetrical about its mean. It has a mean of 0, it still has a standard deviation and a variance, but that value is greater than 1. So this is the important difference between t distribution and normal distribution. And there are actually many t distributions and each of them for 1 degree of freedom. So a degree of freedom or df is referred to as n minus 1. Sample size minus 1 refers to the degree of freedom. So when you increase the sample size, the t distribution will start going to approaches the values of normal distribution and generally it is bell shaped. So the t scores that we get, so just like as for the z distribution we get z scores, for t distribution we get t scores. These t scores can be negative, they can be positive, but the probabilities that we get are always positive. So that's the idea here. So a degree of freedom occurs when every data value is allowed to vary once as a statistic has been fixed. So this is the variation that we generally notice. So for a single mean there are n minus 1 degrees of freedom. Now let's use this principle now. This is how the curve looks like. The higher the degree of freedom, the more flatter the curve on the bottom, and the lower the degree of freedom, the more bulgy the curve. So this is the idea for the t distribution. Now when do we decide between z and t? So when constructing a confidence interval for a population mean, we must always decide between z and t. Now which one to use depends on number one, the size of the sample, or whether it is normally distributed or not, and whether or not the variance is known. If you do not know the variance, always use the t distribution. If you know the variance, use the z distribution. If the sample size is greater than 30, use the z distribution. If the sample size is less than 30, use the t distribution. If the sample is normally distributed, then use z distribution. If the sample is not normally distributed, is in non-normal distribution, then use t distribution. So what are the assumptions that we consider here? So the student's t result only refers to the mean, where the distribution of the population was normally distributed with some mean mu and a finite standard deviation sigma. But this is in contrast to CLT, because for large samples there is no such assumption about normality. So the t distribution is something that requires the assumption regarding independence in the sample. So we'll move away from this jargon. So let's move away to the actual values. So this is the formula for z score. The exact value is the same. We call it the t score. It's still the same formula. It's x bar minus mu. But in place of sigma, we write s by root n. S here is the sample standard deviation. Is the sample standard deviation with n minus 1 degrees of freedom. So how would you find the probability from the t distribution table? Is, let me show you how a t distribution table looks like. So this is an example of a t distribution table. You will see cumulative probability, one tail and two tail. The ones that you need here are at the bottom for confidence interval. So this is the one that refers to the confidence interval. For example, if you have 95% confidence interval and you want to find the probability or the reliability coefficient for 95% confidence interval, then we'll have to look at this column here. So we have to look at this column here. Depends on that value, depends on the sample size. So this row, this column here refers to as df is n minus 1. For example, let's say if n is 10, then df becomes 9, and for the value 9 at 95% confidence interval, the value that you're going to get is 2.262. So this is how we can find the reliability coefficient in t distribution table when you want to calculate the values directly. So the formula here is x bar plus or minus, in place of z alpha by 2, we use the formula t alpha by 2 into s by root n, and with the t alpha by 2 value is found at df of n minus 1. So in the table you will see the confidence interval at the bottom. Use that confidence interval values to find the actual answer. So that's the only way we generally use this. So let's take an example of this data here. So you have 10 randomly selected students. They were asked to list how many hours of television they watched per month, and these are the results. So you have a total of 10 values here. So from the 10 values that we have here, let's try and find the confidence interval. So I'm not going to calculate the exact value every time. So the value here for n is 10. If you take the mean is 86, and the standard deviation becomes 11.842. So we know the formula is x bar plus or minus t alpha by 2 into s by root n. Now here they are asking us to find a 90% confidence interval. So let's go back to the table. So in the table now, so we are looking at a 90% confidence interval. So this is the row that we are looking at, and the sample size n is 10. So df becomes n minus 1. So which is 10 minus 1, which is 9. So for 9 at 90% confidence interval at df value of 9. So in this table you have a df value of 9. The value is 1.833. So substitute the value here. You have t alpha by 2 becomes 1.833. So using that value now, let's try and find the confidence interval. X bar is 86 plus or minus t alpha by 2 is 1.833 times 11.842 divided by root n is root 10. So you have So square root of 10 is 3.1623. So you have 86 plus or minus 1.8833 times 11.842 over root 10 is 3.1623. So from this value you have 1.833 times 11.842 divided by 3.1623. So that gives you a value of 86 plus or minus 6.864. So you have a value of 86 minus 6.864 comma 86 plus 6.864. You have the value becomes 79.1359. So 136 comma 86 plus 6.834, sorry 864 becomes 92.864. So this here is the 90% confidence interval for this data, and this is how you can use t-distribution table to determine the value. Now use the same principle here. So first find x bar, then find s, and finally you have n equal to 5. So they are asking you for 95% confidence interval. In the t-distribution table you have, so n is 5, so df becomes 4. You are looking for 95%, so 95% at 4, the value is 2.776. So the T alpha by 2 value is 2.776. Use this value, substitute into the formula and solve the problem. So pause the video right here and try to solve this problem. So use the same things again. So pause the video and try to solve these problems. So with this, we end our lecture on statistical estimation. So I'll see you guys again in the next lecture.